This is the 26th episode of our Chinmaya Algebra series. And as usual, we are given with an equation in terms of p, that's p minus 1 over p equals 3. And then we are required to find this massive and very intimidating rational expression here. Both the numerator and denominator are of degree 4. So it's quite challenging at first sight. So let's focus first on the required expression. Note that the denominator can actually be factored out as 3 times p to the fourth plus 1. So a good first step here would be to write the numerator, or at least parts of the numerator, to involve p to the fourth plus 1. And in this case, we can do that by considering the first and last term. 2 p to the fourth plus 2 can be written as 2 times p to the fourth plus 1. And then for the remaining terms, we have here p as their common factor. So we can factor out that p as well. So we can write the other terms as p times 3p squared plus 13p minus 3. Now, because here we have an expression that involves a sum of two sets of terms, we can actually rewrite this as two separate fractions. The first one is 2p to the fourth plus 1 over 3 times p to the fourth plus 1, while the second one would be p times 3p squared plus 13p minus 3 over 3 times p to the fourth plus 1. Now this thing here cancels out, leaving us with only 2/3 for the first term. So for the rest of the solution, we would be focusing our attention to this expression here. For now, let's focus on 3p squared plus 13p minus 3. We can rewrite this. Actually, before that, we might as well look at the given equation first. We are given that p minus 1 over p is equal to 3. So that if we multiply p to both sides, we get p squared minus 1 is equal to 3p. So let's take note of this expression. Let's save it for later. And let's go back to this term here. 3p squared plus 13p minus 3. We can strategically regroup this term as 3p squared minus 3 plus 13p. Now, if we factor out 3 from the first set, we get 3 times quantity of p squared minus 1 plus 13p. From this part, we know that p squared minus 1 is 3p. So this thing here is equivalent to 3 times 3p plus 13p. This becomes 9p plus 13p, or simply 22p. So this thing here is equivalent to just 22p, given the relationship or the equation for p. Now let's go back here and substitute what we know. This is p times 22p over 3 times p to the fourth plus 1. This would simplify to 22p squared over 3 times p to the fourth plus 1. We still are nowhere close to the answer we want, but we can do another trick here by dividing the numerator and denominator by p squared, which is equivalent to multiplying them by 1 over p squared. Let's factor out the 22 over 3 here, because that's a constant, and just to simplify the whole term. This becomes 1 over p to the fourth over p squared plus 1 over p squared. This should simplify to 22 over 3 times 1 over p squared plus 1 over p squared. Okay, so we have another term here that involves p squared plus 1 over p squared. We don't know that value, but we know that p minus 1 over p is equal to 3. If we square this, both sides, we get p squared minus 2 times p times 1 over p plus 1 over p squared is equal to 9. This thing here simplifies to 2. So we have p squared minus 2 plus 1 over p squared is equal to 9. We can isolate the variables on the left side to get p squared plus 1 over p squared is equal to 9 plus 2 or 11. So this thing here is actually equal to 11. So we have 22 over 3 times 1 over 11, and that's equal to, cancel this out, we get 2 over 3. So if we go back here, we know this to be 2 over 3. The second term is also 2 over 3. Therefore, the sum that we're looking for is 2 over 3 plus 2 over 3, or 4/3. Therefore, the expression here, this massive, intimidating expression here, is just equal to 4/3. And that's our final answer. It's quite intimidating at first sight, but by implementing our tricks that we learned throughout this series, we can eventually uh, we have eventually made a simple solution for this one. So I really hope you learned something from this video, and thank you for watching. Please do subscribe for more content. Bye bye.